Hello, good morning, everybody. You're welcome to Smart Spark Academy. I will be handling some past questions in organic chemistry. These are chemistry questions you'll be expecting or you should expect in your JAMB examination. So we'll be making a review of them. Thank you. Okay, looking at the board, we have the first questions. These are all JAMB predicted questions, and we'll be making a review of them today. So the first question says, which of these reagents can confirm the presence of a triple bond? Which of these reagents can confirm what? The presence of a triple bond. The first one, we have bromine water. We also have acidified KMNO4, that's potassium permanganate. We also have copper 1 chloride, and we have bromine gas. Now, the first step, when you talk about triple bond, triple bond talks about compounds that are unsaturated. We also have the double bonds. The double bonds as well, what? Unsaturated. Why the single bond? Let me write it for you to see. These are unsaturated, unsaturated. Why the single bond are saturated. Okay? So example of an unsaturated compound, we have compounds like ethyne. Ethyne is an unsaturated what? Compound. The reason is because ethyne has what? Three what? It has triple bond. Is that true? Then if I then have something like ethene, something of this sort, ethene, I have something like this. I can see that these two compounds are what? They are unsaturated compound because they contain double and triple bond respectively. But compounds that contains just single bond are called saturated what? Compound. So there are steps in which we use to identify unsaturated compound. And that step involves reaction with acidified KMNO4 and bromine water. When an unsaturated compound reacts with acidified KMNO4 and also bromine water, it decolorizes the solution. That's one of the tests for what? Unsaturation. But the question here then says, which of these reagents can confirm the presence of a triple bond? The question was very specific. Assuming they asked you which of these could confirm the presence of unsaturation, the answer would have been bromine water and acidified KMNO4. But exclusively to triple bond, the answer is what? Copper 1 chloride. Copper 1 chloride is a specific test for the presence of a triple bond because one common reaction with triple bond is that they can form metallic derivatives. They can form what? Metallic what? Derivatives. Example, copper 1 chloride. We can also have silver chloride, AgCl. It is only the alkynes that are able to what? Form metallic what? Derivative. Okay, now the second question says, name the structure above. Now, the first way to be able to name this structure that is already outlined on the board. Now, you must first understand, identify the functional group that is present in what? This structure. If you observe, you see that the structure have single bonds attached to what? To it. In other words, this structure belongs to a class of organic compound we call the what? Alkanes. It belongs to the class of organic compound we call alkanes because alkanes are characterized by the presence of what? A single bond. So the first step in identifying this structure is to identify the longest chain. To what? Identify the longest chain. How do we identify the longest chain? If I start counting from here, that's from my left side, I see I have 1, 2, 3, 4, 5, 6. I have 6 carbon from my left. If I start counting from here, I still have 1, 2, 3, 4, 5, 6. Right? So the longest chain is 6 carbon. Is what? 6 carbon. And we use the word hex for what? For 6 carbon. When the number of carbon present in an organic compound is 6, we use the word what? Hex. And like I told you previously, that this particular compound belongs to a class of organic compound we call the what? Alkane. How was I able to know that? Because it is characterized by the presence of a single bond, and that single bond accounts for the functional group. So I will then end the corresponding compound with ANE. If I count like this, 1, 2, 3, 4, This is not the longest chain. If I count 1, 2, 3, 4, 5, 5 is not the longest chain. One way that will make you understand this longest chain is that if this was a piping system and I pour water, the point at which water would, the point at which you have flow of water accounts for what the chain that is longer. If I pour water in this first carbon, water will keep flowing till get to this point. Water can also flow down like this. Water can also flow and flow this way. The carbon point at which the carbon at which water will be retained highest is referred to as the what? Longest chain. So if I pour water here, water will keep moving, although some water will enter this side. So which will keep moving, some will enter this side. This pipe here, if this was a piping system, this particular chain will retain more water. In other words, it can be likened to the longest chain. Do you understand? So in this case, now the longest chain is a hexane. The compound belongs to a class of organic compound we call the what? Alkane, because it is characterized by single bond. And we have 1, 2, 3, 4, 5, 6. We have what? 6 carbon. So we use the word hex for 6 carbon. And we use the word ANE because we have single bond. So the parent chain is what? Hexane. So since we've identified the parent chain as hexane, the next step is to identify the substituents. Now, what are substituents? Substituents are other group of atoms that are attached to the parent chain. You can see the parent chain 1, 2, 3, 4, 5, 6. And we have atoms like CH3. We have CH3 as a substituent. Why do I call them substituents? Because they have replaced hydrogen in the chain. Normally, if you look at this chain here, you can see I have CH3. Hydrogen is attached to carbon. You have 3 hydrogen attached to carbon. I have hydrogen. I have hydrogen here. Now, hydrogen was meant to be at this position, but this CH3 has replaced that hydrogen. So, as a JAMBite or someone preparing for JAMB exam, one best way that will make you identify substitute is that any compound that replaces hydrogen in a parent, a parent organic compound, that particular compound is what? A substituent. So in this case, CH3 is a substituent. This other CH3 is what? A substituent. So to be able to name this compound completely, you must think of, if I start counting from the right side or from the left side, at which point will I approach either of these substituents easier? Let's start from the left. Let's start counting. If I call this my first carbon 1, I call this carbon 2, I call this carbon 3. If I start here, I'll meet the substituent at what? Position what? 3, at the third carbon. Let me start from my right. If I have this, I call this carbon 1, I call this carbon 2, I call this carbon 3. You will see that I'll meet the substituent at the same position. Whether I start at the left or the right, I'll meet this substituent at the same what? 3 carbon what? Position. So you can decide to start from the left or from the right. Do you understand? So in this case now, I can clean this side. Why am I cleaning this side? Because if I start from the right, I will still meet the substituent at position 3. So I will have 4, 5, 6. So to name this compound, I will take into consideration the position of the various what? Substituents. The first substituent is at position 3. So I will say this is 3. The next one is at position 4. 3, 4. In organic chemistry, we use comma to separate two numbers together, while we use hyphen to separate number and alphabet. I come again. We use comma to separate two numbers, and we use hyphen to separate a number and an alphabet. So this substituent we have here, we call it methyl. We call it what? Methyl. CH3 is called methyl. CH3 is called methyl. And this methyl is at position 3 and also at position what? 4. And we have this methyl twice, right? So we call it dimethyl. We say 3, 4 dimethyl. We then put back the parent name that is called hexane. So this is what 3, 4 dimethyl. It means that at position 3 and at position 4 carbon, we have 2 methyl group as substituents. You can see the substituent. Then the parent name of the compound is what? Hexane. So it becomes 2, 3, 4 dimethyl hexane. You then go to your option. 2-ethyl pentane is wrong. You can see 3, 4 dimethyl hexane. So this becomes the answer. 3. Then the next question we have here on the board is a very simple question, and it's a question you can understand very well. We have a compound on the board. The name of this compound is called ethanoic acid. It's called ethanoic acid. It belongs to the class of organic compound we call the arachidonic acid. We call what? The arachidonic acid. Their functional group is COOH. When we say functional group, we're talking about what distinguishes a particular compound from various other compounds in chemistry. So if I have something like this, CH3, okay, let me make it more bold. I have CH3, CH2, COOH. I will not call this 1, 2, 3. When you have 3 carbon in organic chemistry, we call it prop. But in this case, you can see COOH. So we call it propanoic what? Acid. Do you understand? So in this case now, this is ethanoic acid. Now, in the reaction, ethanoic acid gave us CH4 and CO2. Now they are saying the reaction above is what? Now let's check the option. The first option says carboxylation. Carboxylation talks about the addition of carbon 4 oxide towards a class of organic compound. But in this case, carbon 4 oxide was not added because you're not seeing a plus CO2 at the reactant side. So that means carboxylation is not the answer. He moved to the next option. We have decarboxylation. In organic chemistry, whenever you hear the word D, then the attach is just more of like a compound word. The main word is carboxylation. Carboxylation is the addition of what? Carbon 4 oxide to a class of organic compound. In the same way, we have hydrogenation, the addition of hydrogen to a class of organic compound. You have halogenation, addition of what? Halogen to a class of organic compound. So we have the word dehydrogenation, it means removal of that hydrogen. Dehalogenation, removal of that what? Halogen. Decarboxylation, removal of that what? Carbon 4 oxide. So in this case, you can see carbon 4 oxide have been removed. So we have CH4 and we have CO2. And remember, CO2 is a gas, right? This one is a gas. So the answer to this question is that the answer is decarboxylation because carbon 4 oxide have been removed from what? Ethanoic acid. Okay. The question I have here again says, that's the fourth question, says the reverse equation of alcohol plus arachidonic acid to give ester and water. JAMB have asked this question many times, and if you watch or if you've gone to JAMB past question, they keep asking questions like this. So please pay much attention to it. Alcohols plus arachidonic acid to give me esters and water. The name of this reaction originally is called esterification. Let me write it on the board. Esterification. Esterification. Why is it called esterification? Because when alcohol and arachidonic acid react together, they produce what we call esters. And esters are characterized by sweetness, by their fragrance. That is why esters are mostly used in the making of perfumes. We also have the likes of Ita. Okay, how you know esters is that they also end with ATE. They end with ATE. Ethyl ethanoate, methyl propanoate, butyl decanoate. So the moment it ends with ATE, just know is what? An ester. Okay? So the reaction between alcohol plus arachidonic acid to give ester and water is called what? Esterification. But now the question says the reverse equation of this is called what? This reaction is a reversible reaction. Alcohol plus arachidonic acid to give me ester and water is called esterification. While water plus ester to give me arachidonic acid and alcohol is called hydrolysis. It's called what? Hydrolysis. Most times, the word hydro talks about water and lysis means splitting. Let me write, hydrolysis is on the board. Hydrolysis. Hydro talks about water, while lysis talks about splitting. So hydrolysis means the splitting of ester by water to form arachidonic acid and also what? Alcohol. Then, okay. Now the fifth question says, we have ethanol on the board and we have concentrated No, leave the question, don't be listening. Okay. Now the fifth question says we have a reaction of this sort. The compound that is listed on the board is ethanol. To check back for nomenclature, you can visit our previous videos to know why this compound is ethanol. Now I'm seeing concentrated H2SO4 at 180 degree Celsius. And we have a compound here that is Y. And that compound is an unknown compound. So they are saying in the reaction above, Y represents what? Dash. To be able to know what Y represents, concentrated sulfuric acid, that's H2SO4, has the ability of dehydration. It's a very powerful dehydrating agent. It can remove water from an organic molecule. So seeing concentrated H2SO4 in this reaction, it tells you that dehydration will occur in this particular compound. Now, I told you whenever you have the word D is like a prefix attached to a compound word or a main word. So dehydration, the main word is the word hydration. Hydration means the addition of water to an organic compound, while dehydration means removal of water from an organic compound. So acids are powerful dehydrating agents, especially strong acids. And H2SO4 is a what? Strong acid. So what happens is that it will remove water from this compound. Let me draw the structure of the compound. This is the compound. I have my H, 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 and I have my OH, right? So if water is removed from this compound, if water is being removed, let me say water is made up of H and hydrogen and OH minus, right? I have H plus, right? So if I remove OH from this position, and also remove H from this position, what will I have? I'll be left with something like this. C, oh, okay, let me use another marker. I'll be left with something like this. I'll be left with C to C. I'll be left with hydrogen, 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 and as well, I'll be left with hydrogen. You can discover that now I've removed water, which is OH and hydrogen, right? But in this case, in organic chemistry, four bonds must always be attached to carbon. Carbon is tetravalent in nature because carbon, the atomic number is what? Is 6. The first set takes 2 and the next set takes what? 4. Right? Now, because we have here 4 as the valence electron, it tells you that carbon is tetravalent. So in this case, that means 4 bonds must be attached to what? Carbon. Okay? Carbon has dual properties. It has the ability to accept electron and also has the ability to give electron because the group 4 elements, they have what you call a group trend. They have both metallic and non-metallic property, right? But the ability of carbon to accept 4 electron is more prominent than the ability to what? Give off 4 electron. Why? Because carbon is a non-metal. As you progress down the group 4, from carbon, where you have the likes of we have carbon, we have germanium, we have silicon. We call these ones metalloids, right? Because as you're moving down from the non-metals, you're passing through the periodic table. The non-metallic property gradually changes to a metallic property. That's why after carbon, you have metalloids, which we call semi-metals, before you start what? Get to the metals. So in this case, all I want to know is carbon is what? Tetravalent. It means 4 bonds must surround carbon. So in this case, you can see that carbon, the bonds surrounding carbon here is just 1, 2, 3. Carbon here is just 1, 2, 3. So the bonds is not complete. One bond must be attached to hydrogen. And you can see one bond attached to the hydrogens. So I will put another bond here. And this bond I'm attaching here now is called a pi bond. I have one sigma bond, or you can call this a sigma bond or the pi bond. Do you understand? So in this case now, this compound is now called 18 is not called 18. Why is it called 18? Because I have 2 carbon. 2 carbon represents what? 8. And it ends with ENE because of the double bonds. So double bonds is for compounds that ends with ENE. Why 8 shows that it has what? 2 carbons. So it's called 18. And this 18 is very useful in the ripening of fruit, which we'll meet in the next question. JAMB always asks this question regularly. Which of these organic compound is used in ripening of fruit? Ethane is used in the ripening of fruit. So in this case, our answer is C2H4. C2, 1, 2, 3, 4. C2H4. So move over to the next question. The sixth question says, in the production of soap, concentrated sodium chloride solution is added to do what? In the production of soap. The production of soap is called saponification. So in saponification process, we usually add sodium chloride. Why? We add sodium chloride to be able to decrease the solubility of I didn't finish this. Okay. The solubility of the soap. Okay. I wrote it somewhere here, but let me just put it down here. To decrease the solubility of the soap. So we always add sodium chloride in saponification reaction to decrease, because these soaps, they are soluble in water. So we add sodium chloride to decrease the solubility, to allow them to precipitate out of the solution. And that process is called salting out. It's called what? Salting out. I think JAMB also usually asks that question. The precipitation process of soap, you understand, in a particular solution by decreasing the solubility is called what? Salting out. So in a nutshell, we add sodium chloride to decrease what? The solubility, okay, of the soap. Then the seventh question is, how many hydrogen atoms does a single ring cycloalkane have less than the corresponding open chain alkane? Let's have a picture of what a corresponding open chain alkane is all about. Okay, now this is a cycloalkane. Let's get the cycloalkane first, because they say that how many hydrogen atom does a single ring cycloalkane have less than the corresponding open chain? Okay, let me draw an alkane. Okay, it's a cycloalkane. Let me draw a cycloalkane first. Which cycloalkane do you want us to use? We can use any cycloalkane. Let's work with cyclopropane. So this is a cyclopropane. It just has a triangular structure. At each point of this joint represents a carbon atom. We don't have cycloethane, because cycloethane will be something like this. There is no line connecting it, right? So from the cyclic compound, the least we can have is cyclopropane, because this represents one carbon, two carbon, three carbon. At these carbons are hydrogens that are attached to them, because four bonds must be surrounded to carbon. Let's count for this carbon. Can you see? 1, 2, 3, 4 attached to this carbon. I will have H here. I have H here. Can you see 1, 2, 3, 4 attached to this carbon? I also have H here. I also have H here. Right? You can see 1, 2, 3, 4 attached to what? This carbon. This is a cycloalkane. Now let's get the corresponding open chain. If I was to draw an alkane that have a straight chain, this will be it. 1, 2, 3. Right? I want to draw propane, because this is cyclopropane. So I want to draw the open chain. How do I do that? A very simple step. Just make sure that four bonds are surrounding carbon. As simple as that, you get a structure. Make sure four bonds are surrounding carbon. And each of the bonds should be single, because we're talking about alkane, A-N-E. So I just have 1, 2, 3, 4, right? 1, 2, 3, 4, right? 1, 2, 3, 4. You then attach your hydrogen. Attach your hydrogen. Attach your hydrogen. How many hydrogens are here? Let's count. 1, 2, 3, 4, 5, 6. In the cyclic compound of cyclopropane, I have 6 hydrogen. Then the normal open chain compound, I have 1, 2, 3, 4, 5, 6, 7, 8. I have 8 hydrogen in the open chain structure. So what the question is saying is that what is the difference between the cyclic compound and the open chain compound? I believe you should have seen the answer by now. So the answer is 2, because 8 minus 6 is 2. Okay? Then I think that's okay for that. Then for the eighth question, number 8 question says, a substance that aids in ripening of fruit is called what? I said it in the previous, the question. Propane, no. Methane, no. Butane, no. Ethane. So the answer is ethane. Okay. The question 9 says, which of the following has an isomer? Which of the following has an isomer? The first question here is, okay, well, I won't start from the first one because the first one is actually the answer. Okay, so let me start from option D. Option D is C2H6. Just ensure 4 bonds surround carbon. Just ensure 4 bonds surround carbon, right? You start attaching your hydrogen, your hydrogen, your hydrogen, your hydrogen. Isomer talks about class of organic compound that have the same molecular formula but different structural formula. So this compound is C2H6. It cannot have any other molecular formula other than this. So this man does not have an isomer. C2H4, which is 18. C2H4. I put my what? My carbon. In this case, the number of hydrogen is 4. That means if I put H here, I put H here, I put H here, I put H here, it will be complete, right? Because 4 bonds must surround carbon. 1, 2, 3, I will introduce another bond here, such that I will have 1, 2, 3, 4, and 1, 2, 3, 4. Four bonds each surrounding what? Carbon. This compound cannot be written in any other way other than this. So this compound is what? It cannot have an isomer because it just has 2 carbon. Compounds that has from 4 carbon up can form isomers. 3 carbons cannot form isomers. Okay? Okay. That's just for compounds that contains just carbon and hydrogen, exclusively towards hydrocarbon. Because in the case of ethanol, ethanol can form an isomer, which we call dimethyl ether. Okay? But that's by the way. So that means these two are not the answers. They are not what? The answers. Then this C6H6 refers to, it refers to benzene. And this is how benzene can be written. Okay? This is benzene. Benzene can also be written like this. Benzene can also be written like this. Okay, let me just change the pi bond placement. I can have something like this. I can have something like this. Yes. Okay. So although yes, benzene is C6H6 and this C6H6. This is another resonance form of benzene. This resonance form, we cannot really or totally liken it to be an isomer in this case because C4H10. Look at this. 1, 2, 3, 4. H, 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 H. You can see all of these compounds. I can rewrite this particular compound, that's butane. I can rewrite it like this. I can write it as C to C to C, and I can put CH3. I put H, 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 H. This compound here and this compound, they have the same molecular formula of C4H10, but they have what this different structural formula. Although benzene have that similarity, but in the case of benzene, we call this a resonance, not necessarily an isomer. Do you understand? So this answer is the most preferred answer. This compound is 2-methylpropane, while this compound is butane. Okay? So this is a resonance form of benzene that can also be called the canonical form of benzene, but it cannot be totally likened to a resonance form of what? Benzene. Do you understand? So the most preferred answer is C4H10. Now the 10th question says, an example of an aliphatic unsaturated compound is dash. The word aliphatic talks about straight chain. Aliphatic talks about straight chain. And the question then says, an example of aliphatic unsaturated. Aliphatic talks about, like I said, compounds that are straight chains. And they say unsaturated, that means the compounds should have what? Either a double bond or a triple bond. Without me writing any structure, looking at the names, let's check. OL. OL, butanol. There is no double bond or triple bond inside. because butanol is just like, it's just butane that oxygen have been added to. Look what I mean. I have one, two, three, four. This H, this H, this H, 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 H. What should be here should be H, two of us. This would have been butane, right? If I remove this H and add OH, this becomes butanol. You can still see it's all single bond. So it's not what? It's not, it's an aliphatic compound, yes, but not unsaturated. I can see ENE. ENE talks about double bond. Talks about what? Double bond. So the answer is propane. ANE talks about single bond. 1, 2, 3, they are aliphatic, but they are not what? Unsaturated. Then benzene is a different class on this one. Okay, then the 11th question, they said the hybridization in the compound above is dash. The hybridization in the compound above is dash. Now, please take this very important. Single bonds are sp3 hybridized. Double bonds are sp2 hybridized. Triple bonds are sp3 hybridized. What I mean is that the carbon attached to a single bond is sp3 hybridized. The carbon attached to a double bond is sp2 hybridized. The carbon attached to a triple bond is sp hybridized. Now, if you look in this compound, you will discover that there are carbons attached to a single bond. Can you see this carbon attached to a single bond? Can you see it? There is also a carbon attached. Oh my God, this was a mistake. This was meant to be C, the H, H. Okay? Yes, so this is it. This was to be C, H2. Okay? Because 4 bonds must surround carbon. So I have 1, 2, 3, 4. 1, 2, 3, then 4. Okay. Now you can see that the carbons here, the carbons attached to this single bond, you can see a single bond. They are what? sp3 hybridized. I can see a carbon attached to a double bond. And carbon attached to double bond are what? sp2 what? Hybridized. So the question then says that the hybridization in the compound is dash. In this compound, we have both single bond and we have what? Double bond. Two of us, single and double bond. So in this case, the answer is B. Why? Because the carbon attached to a single bond is sp3, while the carbon attached to what? A double bond is sp2 hybridized. Is that clear? Okay, maybe you can try this one. You can try for 18. What is the hybridization of the carbon attached to 18? You can try that yourself and check. Okay? Then this next question says the product of the combustion of candle wax are dash and dash. To make us get this question, hydrocarbons undergo combustion reaction to form carbon 4 oxide and water. When we say combustion reaction, is a reaction that takes place in the presence of oxygen. And candle wax belongs to the class of organic compound we call alkane. Candle wax is a very long alkane molecule. Okay? If hydrocarbons, let me clean these options. If hydrocarbons, let me say C2H6, react with oxygen, the product will be what? Carbon 4 oxide and what? Water for every hydrocarbon. So candle wax is a hydrocarbon. So the answer is A, carbon 4 oxide and water. Okay? Then the last question here says, which of these compound has the highest solubility in water? Which of these compound has the highest solubility in water? I have 18, C2H4, I have C2H5OH. The best way that will make you know this question is that just look at the option where this for organic chemistry now. Look at the compound that has OH at the extreme. It gives you a clue of the compound that can be much more soluble in water. Do you know why? Compounds that have OH at the extreme, they can form hydrogen bond with water. And this compound is ethanol. That is why ethanol is much more soluble in water. If you have ethanol, or let me say you have a methanol, you have seen methanol before. We'll call it methylated spirit, right? If you pour it in water, you discover that it can dissolve what in water. So compounds that have OH at the extreme can form hydrogen bond in water. Now, benzene reacts with, that's for the number 14 question. Benzene reacts with hydrogen in the presence of nickel catalyst at 180 degrees Celsius to give what? Whenever you see nickel as a catalyst, nickel has a catalytic property of adding hydrogen to an unsaturated compound. It's what? Add hydrogen. That means nickel catalyst has the capability of causing hydrogenation. What it means is that this is a benzene ring. I have this as a benzene ring, right? Benzene has 3 pi electrons, 3 pi bonds rather, is a mistake. Benzene has 3 pi bonds, 1, 2, 3. And pi bonds are called big bonds. But it has 6 pi electrons. Please take note. It has 3 pi bonds. You can see the 3 pi bonds. 6 pi electrons. Each of the bond contains 2 electrons. So what nickel does is that, what nickel does as a catalyst is to be able to remove these pi electrons by adding hydrogen. So what happens is that each of these, you can see this stuff now, right? It will remove this bond, remove this bond, remove this bond by adding hydrogen to them. So I will then have something like this. Let me clean well so I can draw it very well. I will have something like this, something of this sort. I will have hydrogen, I will have hydrogen, 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 hydrogen. What I now have is, this is not a cyclic compound. It becomes 1, 2, 3, 4, 5, 6. It becomes cyclohexane. Do you understand? It becomes what? Cyclohexane, because nickel has the capacity to what? Hydrogenate an unsaturated what? Compound. Peculiarly what? Benzene. Okay, so I think I have to clean this question so I can have some space. Okay. Then now, the 15th question says, the compound above is dash. The compound above, they put acanol, acanone, acanoate, and acanal. Whenever a carbonyl, this is called a carbonyl functional group. When carbon is double bonded to oxygen, double bond to oxygen, it is called a carbonyl functional group. A carbonyl functional group. If this carbonyl functional group is attached to at least one hydrogen, that compound is an alkanal. If I have hydrogen here and I have arrow, this arrow could represent CH3. This compound becomes what? An alkanal. Why is it an alkanal? Because the carbonyl functional group is attached to at least one hydrogen. So if alkanal is in the option, alkanal is wrong. It can't be the answer. Okay? But if the carbonyl functional group is attached to just alkyl substituent, or is not attached to any hydrogen at all, it becomes what? An alkanone. So if I remove this hydrogen and put arrow here, you can see the carbonyl functional group attached to arrow, which could represent CH3 or whether C2H5, any alkyl of any kind. So you can see this carbonyl functional group is attached to CH3 on one side, right? It's also attached to CH3 on one side. So the answer automatically becomes an alkanone. Is that understood? Okay. Then the 16th question says, the ability of carbon to form chain is called what? JAMB, yes, of course, they normally ask this question. The ability of carbon to form chain, carbon, carbon to carbon to carbon, I have something like this. The ability of carbon to keep forming chains with itself, that ability is called catenation. and is most prominent with what? Carbon atom. Okay, that's for question 16. So the answer here is catenation. Then the 17th questions, I think I will have to illustrate the 17 on the board. Okay, 2-methyl-butanol is an example of a dash. Let me draw the structure. Let me draw butanol first. This is butanol. This is butanol. But they said 2-methyl-butanol. That means the CH3 will be at this position. Because this position 1, 2. So this will be what? 2-methyl-butanol. Okay? Now they are saying is an example of dash. This is the carbon. Can you see the carbon? That is bearing the OH. This carbon bearing this OH is called the carbonyl. It's called the what? Carbonyl. If only one alkyl, or look at it, if only one alkyl family is facing this carbonyl, it is called primary alkanol. If two alkyl family is facing it, it's called what? Secondary. If three was facing it, it will be called what? Tertiary. If I add this OH at this position, for instance, you could see 1, 2, 3 of the alkene is facing this carbon bearing the OH. So this will be called a tertiary alkanol. Then, if there was no CH3 here, if there was H, it will be called what? A secondary alkanol, because this man and this man is facing this carbon. But in this case now, I have the OH here. I have only this man facing this carbon. So it is what? A primary alkanol. Is that clear? Then the last question over here, it says, a hydrocarbon has an empirical formula of CH. When you hear of the word hydrocarbon, it talks about the compound that contains just hydrogen and what? And carbon. Okay? A hydrocarbon has what? An empirical formula of CH. Empirical formula is the simplest formula of a compound that the compound could exist in. Okay? Now, and they say the vapor density is 39. The best way to know the answer to this is that vapor density has a relationship to do with what? Molar mass. So to get the molar mass of this compound, you see that molar mass is equal to vapor density times 2. Vapor density is 39 times 2. 39 times 2 should give us what? What? Will give us 78. So you start adding all this compound, all the molar mass of this compound. Anyone that gives you 78 is actually what? The compound of this. So let's check. We have 3 carbon here, right? Of course, this compound doesn't exist. Can we have something like this? Okay. 3 times. Let's take it out. 3 times carbon, the molar mass is 12. 3 times 12, what do we have? We have 48. 48 plus 3, what do you have now? 48 plus 3 is 51. So this compound is out. This one should be what? Is out. 6 times 12 is what? 72. 72 plus 6 is 78. So automatically this one becomes the answer. Okay, looking at question 19, we have a compound on the board, so we have to identify, name the compound below. Now, to be able to name this compound, we must first identify the longest chain, okay? So I have 1, 2, 3, 4, 5, 6. I also have 1, 2, 3, 4, 5, 6. If I count this way, I have 1, 2, 3, 4, right? Going forward, I have 6 carbon. Going this way, I also have 6 carbon. But 6 carbon is not the longest chain. If we try and work with 6 carbon, you will get option A as the answer. So starting from the right, I have 1, 2, 3, 4, 5, 6, 7. So the longest chain is hept. 7 means hept. Okay? Then now we start putting into consideration where we meet the double bond easier. We'll meet the double bond at position 3. This carbon 1, carbon 2, carbon 3, 4, 5, 6, 7. The double bond is at position 3. So this becomes hept 3 in. Hept 3 in becomes the parent name of the compound. So after having put into consideration the parent name, you start accounting for the substituents. We have substituent at position 3. We also have at position 6, right? So this becomes 3, and we have methyl. We also have methyl. Methyl at position 3 and methyl at position 6. So I'll say this is 3, 6. We use comma to separate with 2 numbers. Then after a number to an alphabet, we use hyphen. 3, 6 dimethyl hept 3N. The reaction of chlorine with alkane is called what? The reaction of what? Of chlorine with an alkane is called generally when halogens react with unsaturated compound, they pull off the pi bond and get attached. Halogens are electrophiles. They are highly electronegative. They pick up the pi bond and attach themselves to that particular compound by a rule called Marconi's principle. So in this case now, addition of halogens or whether chlorine, iodine, bromine to an organic compound is called halogenation. Then if it is chlorine, chlorination, bromine, bromination, iodine, iodination. But halogen is more of the general name for them all. So in this case, the more specific answer is chlorination. Wish to see you, and I'm very, very happy all of you score very well in your JAMB examination. Thank you for having your time with us. We really appreciate it.